Howdy students, this is unit 16.1. We're going to cover in this video oxidation and reduction reactions. In the second video of 16.1, we're going to cover oxidation numbers. So with electrochemistry, we have to understand the flow of electrons. And so if we want to understand where electricity comes from, we need to understand how electrons jump from one place to another. So oxidation reduction reactions, we can actually call it redox for short, because you've got reduction and oxidation. Chemical changes that occur when electrons are transferred between two reactants. And so a long time ago, back in Unit 9 with bonding, we looked at how sodium transfers electrons to chlorine. It has one additional valence electron, and chlorine is missing one valence electron. And so we have a flow from one side to another. So oxidation is the loss of electrons. So in our previous example, when sodium was losing electrons to chlorine, it was being oxidized. So in this example, we have iron plus oxygen, and we'll get into the specifics later in this video, but iron is rusting. It's being oxidated by the oxygen, and same thing for the carbon here. And then another combustion of ethanol can also be considered an oxidation reaction. Now you'll notice with these examples it's pretty obvious because we have oxygens as reactants, but this is not always the case. Sometimes we have to actually look at the Lewis dot structures to see where the electrons are moving. Reduction, on the other hand, is the opposite. We are gaining. So in our first example, the chlorine was picking up electrons because it had one extra space. So oxidation and reductions always occur simultaneously, meaning if you have oxidation occurring, reduction is occurring at the same exact time. You can't have one process without the other. So as one substance, say chemical A, is being oxidized, at the same time, chemical B is being reduced. And you'll see that the electrons are going to travel from what's being oxidized to what's being reduced. So to help us remember oxidation and reduction, we have a couple of mnemonic devices here. And oxidation, we have an oil rig here. And so if we spell out the word oil, O-I-L, oxidation is loss of electrons. And then rig, if we spell out the word rig, R-I-G, reduction is a gain of electrons. So the oil rig helps us remember what redox stands for. And then over here we have a lion, and sometimes we call lions Leo, especially if you're looking at the stars. So if you spell out Leo, L-E-O, that stands for if you lose electrons, you have an oxidative process. And lions go ger. And if you spell out ger, G-E-R, a gain of electrons would be a reduction process. So choose one, whichever one you decide. That's going to help you understand the two processes of oxidation and reduction. When K becomes K positive, it blanks an electron. This means that it is oxidized or reduced. Well, potassium is neutral here. And K plus, positive charge, means that we have lost electrons. So it has lost, and if specifically, it's lost one electron. And because it has lost electrons, it has been oxidized. So here, sodium goes from the neutral atom to the 1+ ion, Na+ when it forms a compound. Therefore, it has lost an electron, it's been oxidized. Now the sulfur goes from being neutral. And in this compound, it has a 2 negative charge. Therefore, it has gained 2 electrons. It has been reduced. So in the next video, we're going to look at how to determine what we call oxidation numbers. And these are going to help us decide whether something has been reduced or if something has been oxidized.